The classes that we have seen thus far have been just normal everyday classes. There hasn't been anything special or out of the ordinary about the classes that we've seen this far. But we can create different types of classes because there are different types of classes and they serve different purposes. There's one that is directly related to our discussion on inheritance, and that is the abstract class. And it's special because we cannot create an instance of an abstract class. Abstract classes are specifically created to inherit from. So you can derive a class from an abstract class and create an object of that derived class, but you cannot create an object of the abstract class itself. So today we are going to look at abstract classes, and it should be an easy lesson because we've already covered all of the hard part, at least as far as inheritance is concerned yesterday. So let's get started by writing an abstract class, and we aren't going to do anything with our person or employee classes. We are going to create a new set of classes based upon shapes because shapes are easy. And the first class we are going to write is going to be called shape. And this is going to be our abstract class. And really, writing an abstract class is very easy because it's a lot like writing a normal class, except the major difference is that we use the keyword abstract. So we have the accessibility modifier, public, followed by abstract, and then class, and then the name of the class, shape in this case. Well, let's add some properties to this class. One is an area, because every shape needs to be able to calculate the area, and therefore if we define it here within this abstract class, then every derived class is guaranteed to have an area property. So let's add it. Let's do public. We'll give it a return type of double because area could be calculated to a large amount of precision. And then the name of this property is area. Now we can also provide an implementation of this area property, but there's a slight little problem. Every shape calculates its area differently, so we can't really take that into account as far as this area property is concerned. So we could do something like throw new, and we have an exception called not implemented exception. So it's basically saying that this property exists, but it hasn't been implemented yet. And we also need to make this virtual because we want the deriving classes to override the area property so that they properly calculate their area. But there's a better way to define this area property because it really doesn't make sense to implement it when we can't really implement it because area is going to be dependent upon each individual derived class. So to show you why there's a better way, let's create a class. We'll call it square, and it is going to inherit from shape. And we're not going to do anything inside of square right now, so it's just simply inheriting it. Let's go to program.cs. Let's create a square object, and then let's use the writeLine method to write the area. So if you think that this is going to throw an exception, you are correct. And that is exactly what we told it to do. There's nothing incorrect about what we are seeing here because we told it to throw an exception. But here's the thing. We might forget to override area inside of square or any other class that we create that's going to inherit from shape. And that's just us being human. We might create the class, go off and do something else, come back, and then forget to do that. So instead of providing this implementation inside of shape, we can actually get rid of the implementation and change virtual to abstract. And this essentially sets up a contract for any class that inherits from shape. Our code is not going to build. If I try to run this, we are going to get a build error. And it's going to say that square does not implement the inherited abstract member of area. So we can't even build our code until we override area inside of square. So let's go ahead and do that. Now we could write that code if we wanted to, public override double and area, but notice that there's this little blue rectangle underneath shape. If we move our mouse over it, click it, it's going to ask us if we want to implement the abstract class of shape. So if we click this, it's automatically going to provide the override for area. All we have to do is change the return value from the get accessor. Now we don't have the sides of the square to properly perform the area calculation. So for right now, let's just return 10. We can run this now, and we will see 10 being written to the console. So by defining area as abstract, we have guaranteed that every class that inherits from shape has to override the area property, which is exactly what we want because the area calculation is up for each individual shape to do. So let's go ahead and flesh out the rest of our square class. We need the length of each of the sides, and a square is really easy, which is why I picked it, because all 4 sides are the same length. So our constructor just needs to accept a single value for the side length. This is going to be double as well. The parameter is going to be called side length. And we also need a property to contain this information. So let's create one that is of double. We'll give it a name of length, and then we will set the set accessor to be private set. That way we can set length inside of our class, and then the area property can now perform the valid area calculation. So length times length. If we go back to program.cs, we need to provide a length here. If we give it a length of 10, then the area of our square is going to be 100. And there we go. Now, before we call it quits today, I want to show you that you cannot directly create a shape object. So if we do new shape, we are going to get a red squiggly because shape is abstract and we cannot create an instance of an abstract class. But we could create a square and assign it to a shape variable. And that is because, as we talked about yesterday, a square is a shape. So we can create a square object and assign it to a shape variable. So if we wanted to, we could use shape down here in console.writeLine, and we would get 144 as the area, which is, of course, 12 times 12. So that is abstract classes. As I said earlier, it's a lot like writing a normal class, but there are some differences. The most glaring being that you cannot create an instance of an abstract class, but also the use of the abstract keyword for abstract properties or methods. And we could demonstrate some methods, but it's the same pattern over again. And since we spent so long yesterday on inheritance, it would be nice to have a short lesson for today. Tomorrow we are going to wrap up this discussion on inheritance with interfaces, which really isn't inheritance. We use a different word called implement. So we will talk about that tomorrow. Have a wonderful day.